Hello students, my name is Mr. Benibo Briggs, your fatherman's teacher. How are you doing at home? I hope you are staying safe and keeping to all the safety guidelines by the Nigeria Center for Disease Control. This video is coming to you courtesy your favorite school, Sleek Angels International School. So now, this will be our first video for SS2 further maths, and subsequently we'll be having other videos. The topic I'll be taking you on today is differentiation. It will be a continuation from where we stopped in class the last time. Okay, so our lesson objectives: we will differentiate explicit functions using first principles. We'll also differentiate explicit functions using the general formula. Okay, some of what you're going to be experiencing today is part of what I've already taught you in class. We'll move from what you already know to the unknown. Okay, so as written here, I said differentiation is the process of finding the derivative or rate of change of a function at any given point with respect to an independent variable. All of this here is something I've already taught you, but I'll just make a brief overview. I repeat, differentiation is the process of finding the derivative or rate of change of a function at any given point with respect to an independent variable. The derivative is a measure of how a function changes its value as the input changes. I give an example. I said if the function f of x is equal to 2x squared plus 3 is a function. For every change in the value of x, there's a corresponding change in the value of the function f of x. Okay? Now, I'll go right straight into one of the objectives we have for today. So our first example says, using first principles, differentiate the function y is equal to x raised to power 3. Using first principles, differentiate the function y is equal to x raised to power 3. This is something I had previously taught in class, but I'll just do this as a reminder before we move ahead. Solution. We have the function y is equal to x raised to power 3. Now, the first thing we're going to do is to have our incremental change. We'll have y plus delta y is equal to x plus delta x all raised to power 3. Y plus delta y is equal to x plus delta x all raised to power 3. If you observe, we have x plus delta x all raised to power 3. So we have to expand x plus delta x raised to power 3. But I previously taught you something like this when I taught you Pascal's triangle. So the expansion of x plus delta x raised to power 3 will have y plus delta y will be equal to x raised to power 3 plus 3x squared delta x plus 3x delta x all squared, finally, plus delta x all raised to power 3. So I repeat, y plus delta y is equal to x cubed plus 3x squared delta x plus 3x delta x all squared plus delta x all cubed. Now everything we have here on the right hand side is equal to x plus delta x all raised to power 3. Okay. Now, next thing we're going to do is to find a way to collect like terms. If you observe, we have y plus delta y, but we are looking for the derivative of the function. So we need just delta y on the left hand side of the equation right now. So that means we are going to be moving y to the right hand side of the equation. And that becomes delta y will now be equal to x cubed plus 3x squared delta x plus 3x delta x all squared plus delta x all cubed minus y. Now, if you observe, when we started this, we said y is equal to x raised to the power 3. So we're going to be replacing this value of y by x to the power 3. So we'll be having delta y is equal to x to the power 3 plus 3x squared delta x plus 3x delta x all squared plus delta x all cubed minus, instead of minus y here, we're going to be having minus x raised to the power 3. Now if you observe here, we have x to the power 3 and we have minus x raised to the power 3. So both of them easily cancel themselves out. And we're going to be left with delta y is equal to 3x squared delta x plus 3x delta x all squared plus delta x all raised to the power 3. Now at this point, we divide both sides of the equation by delta x. We're going to be having delta y divided by delta x will be equal to 3x squared delta x divided by delta x plus 3x delta x all squared divided by delta x plus delta x all cubed all divided by delta x. Now, if we divide 3x squared delta x by delta x, we find out that this can easily cancel this out. So we're left with delta y divided by delta x equal to 3x squared. Now, we have delta x all squared multiplied by 3x divided by delta x. So if we divide this by this, we're going to be left with 3x dot delta x. Remember, as I said earlier in class, dot in mathematics represents multiplication. Now, moving on to the next one. Plus, we have delta x all cubed divided by delta x, and that leaves us with delta x all squared. Delta y divided by delta x is equal to 3x squared plus 3x dot delta x plus delta x all squared. At this point, we are going to be looking for the limiting value of delta y by delta x as delta x tends to 0. Now, if we are saying we are looking for the limiting value of delta y by delta x as delta x tends to 0, just like what I previously taught you in class, it means that at every point where we find delta x, we substitute delta x for the value 0. So we're going to be having 3x squared plus 3x dot, as I said earlier, wherever we find delta x, we replace it with the value 0 plus 0 or squared. So it means that the limiting value of delta y by delta x as delta x tends to 0 becomes dy over the x, which is 3x squared. Because 3x multiplied by 0 gives us 0, and 0 squared gives us 0. So 3x squared plus 0 gives us 3x squared. This is the derivative of the function y is equal to x raised to the power of 3. Okay? Just a soft reminder, and we'll move on to the next example, example 2. Okay, so that was a soft reminder of what we had previously done. Now we're moving on to example 2. The general formula. So the general formula for finding the derivative of a function y is equal to x raised to the power of n is dy over dx is equal to nx raised to the power of n minus 1. Also, the formula for finding the derivative of a function y is equal to ax raised to the power of n is dy over dx is equal to anx to the power n minus 1. Just like I had previously explained in class. Now if you observe here, we have y is equal to x raised to the power of n. If you observe, the coefficient of x raised to the power of n here is 1, while the coefficient of x to the power of n here is a. This has a scalar multiplying x to the power of n. That is why we have a slight difference. The only difference we have in the formula is in this point where we have the scalar multiplies the value of dy over dx over here. Okay? So we move on to try to use the formula to derive functions, find the real functions. Now, example 2 says, using the general formula, find the derivative of the function y is equal to x to the power 3. If you remember, this is the function we used to solve in the first example. So we are going to try to use the formula method to see if we get the same value as what we got using first principles. We have y is equal to x raised to the power 3. And we said according to the general formula, if we have y is equal to x raised to the power n, the general formula tells us that the y over the x is equal to n multiplied by x raised to the power n minus 1. So in this case, since we have y is equal to x to the power 3, then looking at the general formula, the y over the x will be equal to our n, in this case, is 3. So 3 multiplied by, according to the formula, x raised to the power n minus 1. Once again, n is 3, so we are raised to the power 3 minus 1. 3 minus 1 is 2. So finally, the y over the x is equal to 3x raised to the power of 2, just like what we had previously. So if you observe, you can see that the formula method is slightly faster to achieving our aim. We move on to example 3 that says, find dy over dx if y is equal to 5x raised to the power 4. Now, for example 2, you observe that I used the first formula here, okay, where y is equal to x raised to the power n. But for example 3, we have a scalar multiplying x to the power 4. We have 5 multiplying x to the power 4, which means we are going to be using this formula. Okay, solution. Since we have y is equal to 5x raised to the power 4, same thing as having y is equal to ax raised to the power n, where we have dy over dx is equal to anx raised to the power n minus 1. So if we try to apply what we have here to this, we have dy over dx will be equal to, in this case, our a here is 5. So 5 multiplied by our n here is 4. Multiplied by 4, multiplied by x raised to the power n minus 1. Since n is 4, we have 4 minus 1. And 4 minus 1 is 3. So finally, dy over the x will be equal to 5 times 4, which is 20. So we have 20x raised to the power of 3. This is the value of dy over dx. Now we move on to example 4. So the value of dy over dx is 20x raised to the power of 3. Now we move on to example 4, where we encounter the derivative of a sum. It says, find dy over dx if y is equal to 4x raised to the power 3 plus x raised to the power 6. If you look at this now, when I say the derivative of a sum, if you look at the value of y, we have two independent variables. We have 4x raised to the power 3, and we also have x raised to the power 6. And they are asking us to find the derivative of y with respect to these two independent variables. So we have y is equal to 4x power 3 plus x raised to power 6. Now we know that mathematically we cannot add 4x power 3 plus x raised to power 6 to become a single entity, because the powers of x in these two cases are not the same. So we say the y over the x. Here, firstly, we treat each of them separately. Here we have 4 as a scalar multiplying x power 3, but here there's no scalar. The value of x power 6 here is 1. So we're going to be applying this formula here, an x power n minus 1 for x raised to power 3, where we have y over the x will now be 4 multiplied by the power 3 multiplied by x raised to power 3 minus 1, plus, moving on to x power 6, we're going to be applying this formula, nx raised to power n minus 1, where our n here is 6 multiplied by x raised to power n minus 1, which is 6 minus 1. So this becomes, well, the x is 12x raised to power 2 plus 6x raised to power 5. This is the value of the y by the x. Example 5 says, what is the derivative of the function 3x squared minus 7x plus 4 with respect to x? Solution. Our function y is 3x squared minus 7x plus 4. And they are asking us to find the y over the x. This is another example of the derivative of a sum, because this is the sum of 3x squared minus 7x and 4. So we're going to be treating each of them separately. But if you also observe here, we have 4 as a constant term. Why is it a constant term? Because the coefficient of x here is 0. Okay, so the y over the x will be differentiating this 3x squared on its own, which will be 3 multiplied by 2 multiplied by x raised to power 2 minus 1. Okay, we have minus 7 multiplied by x. Now if you observe here, when we have minus 7x, the power of x here is 1. Okay, if the power of x here is 1, then applying n minus 1, we have 1 minus 1. Okay, now if you remember, as I told you previously, 4 is a constant term, and I had always told you when we began this topic in class that the derivative of a constant is always 0. Okay, because if we're having 4x here, 4x, now the derivative of 4 will give us 0. Okay, this will now become 6x raised to power 2 minus 1, which is 1, minus 7x raised to the power of 0, because 1 minus 1 is 0. Finally, the y over the x will now be 6x minus 7. Why is it 6x minus 7? Remember, say any number raised to the power of 0 is 1. So x raised to the power of 0 is 1. And 1 multiplied by minus 7 gives us minus 7. So the derivative of the function 3x squared minus 7x plus 4 is 6x minus 7. So we'll move on to the next stage. Okay, now we'll move on to chain rule or function of a function. What do we mean by a function of a function? If y is a function of u, and u on its own is a function of x, it means that y is dependent on u, and u on its own is dependent on x. So, for us to be able to find the y over the x, meaning the rate of change of y with respect to x, if you remember, looking at what we have here, y has nothing to do with u. y is dependent on u, and u is dependent on x. Y on its own has nothing to do with x. But because it is dependent on u, and u on its own is dependent on x, then first we have to find the derivative of y with respect to x. We have dy over du multiplied by du over dx. I repeat, dy over dx will now be dy over du multiplied by du over dx. Ordinarily speaking, if you look at this, you may easily say, if we divide du by du, if it cancels itself out, we'll be left with dy over dx. Now we're going to try to apply what we have here to problem solving. Okay? Example 6 says differentiate y is equal to 3x squared plus 7 all the raised to power 2 with respect to x. I'll try to use this example to explain the chain rule. Let's go ahead. Solution. So y is equal to 3x squared plus 7 all raised to power 2. Now we can make an arrangement and say, if you observe, 3x squared plus 7 is a function, all raised to the power of 2 is another function. So we can say, let u be equal to 3x squared plus 7. Okay? If we say let u be equal to 3x squared plus 7, coming over here, we'll now have something like y is equal to u raised to power 2. If y is equal to u raised to power 2, then it means that dy over du will now be equal to 2u. Okay? I'm not going to be doing 2 minus 1 because 2 minus 1 is 1 and u raised to power 1 is u. So if y is equal to u raised to power of 2, then dy over du, which means differentiating y with respect to u, gives us 2u. Remember, they are asking us to differentiate y with respect to x, so we are not done. Now looking at this, we said let u be equal to 3x squared plus 7. If u is equal to 3x squared plus 7, then differentiating u with respect to x, that will be du over 3x, that will be 3 times 2 times x. Remember, 2 minus 1 is 1, so I won't be doing that anymore. Okay? Now, if you look here, 7 is a constant term, and I said the derivative of a constant term is 0. So I can just add plus 0, and this will give us 6x. Okay? 3 times 2 times x gives us 6x. And since we are looking for the derivative of y with respect to x, we're now going to come back to this formula, which is the chain rule we're referring to. And we have a function which is a function of another function. So applying chain rule, we have dy over dx is equal to dy over du multiplied by du over dx. So we ask ourselves, what is dy over du? Dy over du here tells us 2u, we place it here, multiplied by du over dx. Du over dx is 6x. But remember that we said let u be equal to 3x squared plus 7. So replacing u with 3x squared plus 7, we'll have u over dx as 2 multiplying 3x squared plus 7 multiplied by 6x. Okay? So 2 times 6 times x, we have dy over the x will give us 12x into 3x squared plus 7. This is the value of dy over dx. this represents the function of the function. Now, onto your assignments for the day. You have number 1 saying, using first principles, differentiate A, 6x raised to the power 5, B, 3x plus 5 all raised to the power 4. Number 2, using the formula method, differentiate A, y is equal to 3x to the power 4 minus 2x raised to the power 3 minus 7x plus 5. B, y is equal to bracket open x minus 3 bracket close, bracket open x minus 4 bracket close, bracket open x minus 5 bracket close, and bracket open x minus 6 bracket close. So we have x minus 3, x minus 4, x minus 5, x minus 6 all multiplying each other. Well, for C we have y is equal to 5x to the power 3 minus 2 all raised to the power minus 1 over 2. Okay, so I'll be expecting your returns. You have my WhatsApp contact here, 0806 361 0526. You can also send your answers to my email address, askbenny247@gmail.com. I trust God you will stay safe. God bless you.